Bluebird vertical takeoff and landing UAV works. It has propellers facing upwards in the back while this side rotates counterclockwise. The other propeller opposite it rotates in the clockwise direction. This configuration is designed so that the rotor's reaction torque is cancelled, stabilizing the UAV and preventing it from spinning uncontrollably. Once the VTOL flight is stabilized, the UAV can transition into forward flight mode, utilizing its 50cc two-stroke engine. However, this is no ordinary UAV. It has the capability to scan a car's number plate from many meters away and map out an entire environment, all without the need for a pilot. Unlike traditional UAVs that require a runway for takeoff to complete their missions, the Bluebird unmanned aerial vehicle can accomplish the same mission by launching from anywhere, even closer to the target. In the upcoming video, we will take a closer look at the interior of this UAV, so stay tuned and don't miss a beat. With this video, we're doing something different by studying Bluebird electric-powered Thunder B and Wander B VTOL unmanned aerial vehicle that could be operated from maritime ships. It can also operate in congested urban buildings as well as forest clearings. It does this by combining the advantages of multicopters and fixed-wing UAV, switching from vertical to horizontal flight mode when taking off and landing. But why do we need vertical takeoff and landing with fixed-wing aircraft? Many aircraft, such as the V-22 Osprey, as well as the American fighter jet F-35B, use this technology to operate in confined places or platforms. The V-22 Osprey uses these huge rotors to lift the helicopter, and when it has reached a certain height, it switches to traditional fixed-wing rotors, giving it range and speed. These are also very complicated engineering done by the F-35B, as shown here in the animations. It switches from vertical takeoff to horizontal flight mode suitable for almost all terrain environments. Let's look at these drones and the advantages and challenges of VTOL technology engineered for Thunder B and Wander B UAVs. Number 1. It has to be lightweight. Number 2. The aerodynamics has to be engineered to lower fuel consumption. Number 3. Propulsion with the 5 motors. They have to operate seamlessly in all weather conditions. They use 4 quad electric motors for vertical takeoff. And as soon as they have achieved a suitable height, they switch off the 4 electric motors, turn on the pusher engine to move forward. Interestingly, the 4 electric motors align themselves, just like the animation shown here, for aerodynamic purposes. The only scenario is in bad weather conditions where the 4 electric motors work in conjunction with the pusher engine to stabilize the UAV from spinning all over the place. Number 4. Cube assist used for VTOL technology. This means it has to land in a harsh maritime sea environment on top of a landing deck of a ship that moves along with the waves. The top-secret technology and software helps to pinpoint the drone to even land on autopilot mode. Compared to other long surveillance drones, they need a runway to attain sustainable lift, just like these drones shown here in the animations, which is a disadvantage when they have to operate when there is an emergency landing requirement. Let's consider this scenario. This is the landing area for the UAV, and the mission objectives are located around 50 miles from the border of another country. A standard fixed-wing UAV will need a runway to achieve liftoff. And most importantly, it will take double the amount of time to travel to reach its designated mission objective as shown in this animation. In contrast, the Thunder B VTOL can position itself within 10 miles of the border and travel to its designated mission objectives. After completing the mission, it can travel and accomplish the mission by traveling only half the distance and taking half the time in comparison to its counterparts. Also, we should note the cons or disadvantages of a catapult-launched unmanned aerial vehicle. They also rely on the initial launch force from the catapult, which may result in a different level of endurance or long-distance capabilities compared to traditional propeller-driven UAVs. But there's a downside. Due to their launch mechanism and design, catapult-launched unmanned aerial vehicles often have limited payload capacity. This restriction can be a disadvantage when it comes to carrying heavier equipment or payloads. Moreover, catapult-launched UAVs have a higher risk of damage as they require a parachute for landing. This can subject the drones to greater stress and impact forces, thereby increasing the risk of damage or component failures. Let's look at the advantages of fixed-wing UAVs. Number 1. Fixed-wing UAVs provide long-endurance flights with the advantage of fuel savings. Number 2, they help the drone resist severe weather conditions. Number 3, fixed-wing aircraft can also glide in case there's an emergency engine failure, low fuel, or battery. Now let's take a closer look at these two unmanned aerial vehicles. Starting first with the Thunder Bee VTOL. This UAV has a wingspan of 500 centimeters or 16.4 feet and has a winglet that decreases drag. Moving to the side, it has a length of 245 centimeters or 8 feet and weighs around 40 kilograms or 88 pounds. While the Wanderbee VTOL, which is smaller, has a wingspan of 345 centimeters or 11.3 feet, a length of 175 centimeters or just 5.7 feet, and believe it or not, it weighs just around 15 kilograms or 35 pounds. Even better, let's compare both UAV to a person to help us understand their size. Interestingly, the smaller drone's main power plant is an electric motor that has a speed of around 65 kilometers per hour or 40 miles per hour with a maximum flight ceiling of 16,000 feet. This drone also has a communication range of 50 kilometers, which is good considering its unique size. While the Thunderbee VTOL main power plant is a two-stroke 50cc engine that propels the UAVs to an astonishing speed of 75 kilometers per hour or 40 miles per hour. Amazingly, this unmanned aerial vehicle has an endurance of 12 hours or more. This is the Wanderbee VTOL unmanned aerial vehicle. It could also be divided into several parts. The most important part is the fuselage, which stores the brain and battery electronics supported by a main wing. The wings can be attached just like the animation shown here. Moving forward, these are the booms required for the vertical takeoff and landing propellers to lift the drone vertically. And the last ones are the tails, fixed in such a way that they support each other, which helps stabilize the drone. Let's take a quick look inside the cover of this Thunderbee VTOL UAV. At the front sits the flight and mission computers, and just behind them are the VTOL batteries that power the 4 electric propellers, which can be attached or detached when needed for recharging. At the back is the camera payload, and the best thing about this is it is interchangeable. Just behind the payload is the fuel tank that powers a 50cc two-stroke engine. Similar to traditional aircrafts, they do have air intake for the engine and a hatch for the fuel pump. Here comes the main wing attached to the main fuselage. These are the booms required for VTOL propellers to lift the UAVs vertically. Notice the difference. These two propellers on the front are faced downwards, while the ones on the back are faced upwards. 2 tails could be attached to the back of the unmanned aerial vehicle for stability. Another wingtail is joined together, helping it gain additional lift when in forward flight. And the last part is the wings, which could be attached as shown here in the animation. The amazing thing about this UAV is it could be assembled by a one-person crew in under 20 to 25 minutes. This is how it works, explained through super simplified animations. The air flows and moves through the aerodynamic rotors. These blades are designed in such a way that they produce lift as shown in these animations. But wait, that's not it. If we look closely at the front propellers, they are faced downwards. While this side rotates in a counterclockwise direction, the other rotor rotates in a clockwise direction. Moving to the back, the propellers are faced upwards. This propeller rotates clockwise while the opposite side rotates counterclockwise. This is done so that the rotor's reaction torque gets cancelled, stabilizing the UAV from spinning all over the place. Once the VTOL flight is stabilized, the UAV will then transition into forward flight mode using its 50cc two-stroke engine. Interestingly, the flight path will work like traditional planes. This is not just an ordinary UAV, but the payload system that could carry this electro-optical and infrared and imaging systems used for military or law enforcement applications, including visible and infrared sensors. To demonstrate its effectiveness, let's take an example of this vehicle. As you can see, it can even track a moving car, and its stabilized video image can even read cars' number plates several meters above the ground. These Bluebird UAS can also be deployed on autonomous mapping missions to collect and automatically send data into 3D high-resolution analysis software. It can accurately detect the volume calculation as well as the area calculation of a building. This is useful for 3D mapping in urban area. An autonomous drone is useless without uninterrupted communication. Let's look at what happens when there is non-line of sight interruption. An operator solves this problem by assigning two UAV platforms 1 and platform 2 as shown in the animations. If there is a signal interference, they can form a connected network and send data to the ground control station.